Hello and welcome back. My name is Corey, and I guess you're my rubber ducks for the evening. And this is the series where we are creating a programming language from scratch. That is, we've designed it, and it's called Tang, and it is a template language. It's the name T template Ang language Tang. Anyway, and so the goal of this language is that it's supposed to be non-trivial, right? It's not just one of your silly, simple examples that you find everywhere, but this is intended for actual use, and we will be doing the goal is to have this as a library that could be embedded in another program that you write, I should say. And its goal is that it should be able to produce HTML output by providing a scripting language of sorts to a designer, perhaps. I'm thinking, should I talk about the why would I even want to do this when there's other languages out there? Yeah, one of the reasons is because some of them are too powerful. They would allow the designer to open a file on the computer or open a network connection or things like that. It's like we don't want that. So, okay, that's what we're trying to do. We're trying to limit the power, but still give something that is very expressible, very powerful, and then it will do a lot of the work security-wise for the designer. We're using just a handful of bare tools. We're using Flex and Bison, Google Test, ICU, and Vim is our editor. We're doing this 100% in the terminal window, and I've said it before, there's nothing up my sleeves. I don't have anything pre-prepared. You're seeing this, one of the reasons I'm recording this is because it is to document a non-trivial project from start to finish. So this is episode 60, and the name of this, what did I call this? The Great String Refactor. Print output. What does that mean? Well, we need to rework how we're dealing with strings. Right now, our string processing is kind of nice in that we've got our own class for dealing with strings. And the reason is because we are integrating ICU, their Unicode support, get those words separate, of graphemes, identifying those units of characters that are seen as, they're together, they're indivisible. But they may take up multiple code points, and multiple code points, if they're a large code point, it may take up multiple bytes. I think like the flag of Scotland has, is it 6 or 7 code points and 27 bytes, and those need to be together always. It should never be reversed. It should be seen as a unit. And I'm not aware of any code bases that are doing that, any languages, but this one is. So what's the problem? Well, we spent a lot of time writing Flex stuff, and we're storing strings in UTF-8 internally, and then, well, if we need to parse that or dissect that out and get the individual code points for this or that reason, for example, HTML encoding, well, we've got some libraries for that, but we never actually tied it into our system. And the reason is because I realized that we had a problem that I didn't have the time to deal with. I didn't know of a good solution, and I'm still not going to claim that I do know of a good solution. But we're going to, we're just going to go from right here, right now, and going to come up with a solution for some of these things. And I'm calling it the Great String Refactor because we're going to have to rethink how we deal with strings and restructure our class a little bit. And so let me tell you the problem. First of all, our current way of dealing with strings is that we have a string class and we store the string as a UTF-8 encoding, and we just use the internal string class. And we've got a few functions that we could, for example, perform an HTML encoding. We haven't written our percent encoding thing yet, but we could. Anyway, we've got an HTML encoding, but we've got two types of HTML encoding functions. We've got one that will just encode the dangerous characters, and one that will encode everything as ASCII characters. So it won't. The first one will only take the dangerous things and encode them. Dangerous things like the angle brackets, open and close, and the ampersand. But everything else, it will just leave a standard UTF-8. And as it turns out, that's how the web works. That there are UTF-8 encoded websites, and it just sends the UTF-8 encodings, and it only escapes things when it doesn't want them interpreted as actual HTML. And that's fine. But there are times where it's like, no, I want everything encoded. I want it encoded as ASCII, but I need to represent these Unicode points. And so that's what the second function is for. And the problem is well, what if we have some output that, a username, for example, that should be encoded, but we don't know the type of encoding that it needs. Does it need to be encoded in UTF-8 and just the scary stuff, the dangerous parts, escaped? Or does it need to be encoded in ASCII, and in which case everything is escaped? Or maybe there's something else, the percent encoding. We don't know how to handle that. And the reason I'm saying this is because, well, that's just one part. I mean, we could write something as it is right now and handle that case. But what if that one thing is then the username is rendered in a larger context? Well, then that would be an output variable. And if it's already encoded, then we get into the problem of, oh wait, are we going to do a double encoding? That could be dangerous. And so what I think we need to do is, for our strings, our string class, we need to store them as separate parts. What I mean by that, we need to store them as separate parts is the best way I can put it. Each chunk as this is a section and it is considered unsafe. This is a section and it's considered safe. And the unsafe should have the HTML escaped. The safe should not have the HTML escaped. Why? Because probably a designer gave it to us and it's supposed to have HTML embedded in it. You don't want to escape that. And it could be mix and match. And the idea is, in a larger project, you would have one template that would perhaps render a display name. And then the output of that would become a variable in another template. And then that gets rendered and it goes to the output of another. And so it would pass along, and these variables would just grow and grow and grow. And that's what, or that's what we're thinking the overall, the end result would be. Okay, so I know it just kind of stopped. It's because I'm, thinking through this. And the question is do we want to... Yeah, that's what we're going to do. We're going to modify our string class so that it can represent different chunks of output and combine them appropriately and do it as efficiently as possible. That's the goal. That's what we're going to do. All right. Having said that, let's get started. First of all, we're going to, I've always said nothing up my sleeves, don't have anything pre-prepared. If I say git log, the last commit was the end of episode 59. And if I say git status, it does say that there's one file difference. So let's see what that difference is. And all that I did is in the to-do list, I took out that code comments because that's what we added in the last episode, and I just forgot to remove it from the to-do. So the first thing we're going to say is git commit and just remove code comments from the to-do list. Okay, that works. And now we're clean. And we're going to start off, I think, let's start off with the program. Oh, on the right-hand side, normally what do? I say on the right-hand side, make clean. That removes everything, and then make test watch. There we go. And so that'll start our compilation process. So first, this is, by the way, the first in a series of videos that's going to take place. And what is that series of videos? Of refactoring. So the goal for each video is to always be at a compilable place, a steady, a solid. What word am I looking for? I don't know. It's 11 o'clock at night for me, so words sometimes fail me. But we want to get to a place where everything is still working, okay? And all of our tests are passing. It still compiles. So that's the goal. So as we change, and as we do commits, we want them to be at those points. So the first thing is we're going to edit I'm going to look at the program execute. Okay, just for the moment. And the reason is I want to look at how does the print work? Well, okay, so when we say to print something, why am I doing this? Well, right now, I was pretty sure this is what was happening, and I think, yep, right there, this line. This arrow out, which is a string, is we're doing a plus equal to result arrow dump. What is result? Result is the result of this expression arrow string, and I don't have a WSL view of our not include docs HTML index. I've been trying to type in index for the last there we go. And what I'm wanting to look for is this the dunder string on the expression. So on computed expression, there we go, dunder string. Or aren't these in alphabetical order? Does anybody know? I don't know. Perform a typecast to string, but it returns a garbage collected value. So we're presuming it could fail. But assuming it returns a garbage collected value, then, well, let's go back to our code. We say if it's not an error, then we call the dump on that. And I think, again, that's a garbage collected value. So what is garbage collected arrow dump? I'm looking for it. Oh, no, wait. I'm wrong. Because it is a garbage collected value, but when we call the arrow, it does resolve to a computed expression. So it's the computed expression arrow dump. Forgot how my own library works. It happens. There we go. It just returns a standard string. And I'll put the contents of the computed expression as a string. Didn't we already do that? things. So I don't like that. What does the computed expression string contain? So computed expression string, right there. It has a val, which is our Unicode string. And that makes sense to me. And what I think we're going to have is, instead of the Unicode string, we're going to have an array of Unicode strings. Or not an array, a vector, really, of Unicode strings. And as we yeah, as we need to look for something, so to speak, in this, um, yeah, we just each Unicode string would represent a part that is either, say, trusted or not trusted, or how it needs to be encoded. Perhaps is this an HTML, the default, or should this be a string encoding or something like that? Still thinking about that, but I do like the idea of a computed expression string, instead of just having this val, having it as a vector of Unicode strings, and then do we have anything that returns that converts it to a string, not a string stream like in C++, but I mean an actual string? And I think that is the dump and the as code. All right. Okay, so I think I kind of have an idea of the direction I want to take. First of all, the output. I want to use a computed string, and so instead of this line here, I don't want to add it to out. I wanted to add it to our computed expression string, and result. We're not going to call result arrow dump. We're going to have it as a string. Yeah, that's what we're going to do. All right. Have a plan of action. So I'm going to start off with editing the include for the program.hpp. And what are my includes here? I have a computed expression here. I'm going to include the computed expression string. Yes, computed expression string. And we're going to have, so there is the output of the program resulting from the program execution. I'll think about this, but for right now, I'll just add another one, and this will be the output of the program as a computed expression string. And this is going to be a computed expression string should that be a garbage collected value? Actually, yes, it should be. Oh, I don't like doing it that way, but that's what we're doing. Yes, garbage collected So I don't need to pound include the computed expression string here. And this is going to be the I know I'm thinking about what I want this to be called. Dunder out. Should this be protected? Perhaps. No. Let's not protect it. And to say, hey, if you mess it up, that's on you. And then the other thing I said was that I actually don't need to pound include this here because I just see the garbage collected. Okay, and now we need to edit the source. Oh, on the left-hand side. The source for program.cpp. And I don't have anything as the out. Computed expression string. And where is this in the list? The dunder, not a dunder out, but the underscore out. That's a really bad. How about just computed expression out? I'll use the long form. I don't care. All right. And that goes before out, which is the first thing. Okay. And what is this? This is going to be a garbage collected make computed expression string. Can I feed it nothing? No, I think I need to give it an empty string. And so what's the problem? Why was it giving me an error? Well, it's because computed expression, the computed expression string, the garbage collected is as a bare constructor is protected. You can only create one through this make whatever. And because I didn't have this initializer here, it was trying to do a default initialization, and that was protected, so it couldn't do that. So that's why it was giving me the error. Okay, great. All that to say is we're 24 minutes in, and we added a garbage collected value as the that we're calling computed expression out. Now, for the real work. What we're going to do is we're going to say, I'm going to change this a little bit. If the type ID of star result is equal to the type ID of computed expression string. Then this arrow computed expression out computed expression string plus equals a static cast as computed expression string ampersand of result. Yeah. Else, if the type ID of the star result is equal to computed expression error, then pass the error. No, we can undo that. I'll leave it as it. If it doesn't equal error, then forget that. I'm not going to add it. I'm going to say oh, I forgot to do that. There. So, okay, let's back up. If it is a string, then I'm going to just add that to my string out and push an empty value onto the stack. Okay, that's fine. Else, if it's not an error, then I'm going to say string returned neither a string nor an error, so report that. And stack pushback garbage collected make computed expression error, and we're going to give it an error argument recognized as a string or error type. How about that? Okay, so first we're saying if it's a string, then you know what? We know that our computer expression string, we're just going to treat it as our computer expression out is going to be a computed expression string. And we're going to static cast this because we already checked. We know that it's a computed expression string. We're using the plus equal, and the plus equal will allow us to write something specifically for a computed expression string that will efficiently move the resources into the target string. Yes. Having said that, I now know that this should not be public. Our computed expression out should definitely not be public. We could return a computed expression to 1, which is very efficient, but it should not be public because we don't want anyone to ever be able to change the value of it because for the sake of efficiency, we're not checking for the type. So we will make that non-public in just a moment. Okay, so first, is it a string, which we anticipate it will be, so that's our first check. If it's not an error, however, then we just give an error that, yeah, it's not that. But the last is, it is an error, not should be. Return an error. Pass that back to the stack. Okay. That should be fine. It's going to complain. We don't have the... Oh. There. Now it's going to return an error. And what is the error? It doesn't know how to do the plus equal. That's what we're about to write. So, edit the include for the computed expression string. And we've got all of these and string operator plus equals, and what's it going to take on the right hand side? A const computed expression string ampersand RHS. There. And let's add helper function to copy the contents of the RHS string into the current string. And we've got an at param of RHS, and that is going to be the right hand side of the operation. And at return is going to be the result of the operation. All right, and now we need to edit the source for, what do I have? That's in program execute. I'll get that in just a second. Computed expression string, and we'll go down to the very bottom and just add that, and just for the moment, oh, you know what? I can probably just say this arrow val plus equals RHS. No, RHS dot val, and then return it. That is not quite right, but okay. let's see. Oh, I don't have an operator for the Unicode string plus equals. It's a Unicode string. Drat. Okay, that's fine. Let's edit that. The include for the Unicode string operator equal and less. And oh, there's the operator plus. Plus equals, and this is basically not a const. All right, so it's going to say shouldn't this be an ampersand because we're returning ourself? I would think so. Which probably means it needs to be an ampersand on the previous. And an ampersand here. And now, let's keep going. I'm not even looking at the errors in compilation. So this is create a new Unicode string that is the concatenation of two Unicode strings. Nope, we are going to concatenate the RHS string to the current. Wait. Unicode to the current Unicode string. The string to append to the current, the result of the concatenation. I think that will work. Okay. And now we need to edit the source for Unicode string. And we're going to look for operator plus. There we go. We put it after it, didn't we? You know what? Who needs that? Let's just... plus equals. It is not const. There. And okay. So now we've got a Unicode string that will add to itself. And now we're back to the program execute. We've got something wrong there, but that's fine. Oh, it's the very first one. And line 600. There we go. We just need another closing parentheses. We are failing all of our tests. Is that what you would expect? That's what I expect. Why? Because we are no longer writing to out. So all of our tests that rely on the output are going to fail. All that we're doing is we are doing this, where is it? The computed expression out, we're adding it to that. So let's go to the program execute. That's B1, right? So here we're executing, and all that we need to do is when we're done, PC equals stack size. So this is verify that there's not. Empty the stack, but save the top of the stack. And then the last thing we're going to say is render the output to out. And what we're going to say, this arrow out is equal to this arrow computed expression out arrow, what is it, dunder, is it dump? There's a quick way of finding out. Here we go, computed expression, whatever, string, but yeah, dump. That should be right. Oh, not a dunder. Oops. Everything's still failing. Why? Why does it fail? Let's start with a it's only in the normal tests, and can I focus on just one is what I'm thinking. Okay, I'll tell you what I'm thinking right now. When's the first time we use out? Is dot out, is the first time on line 608? So I'm just going to search for out. 608 is the first time we use out. Okay. So in other words, I was thinking, that seems really, really far in. Is it that it's always failing, or is it only failing when I'm dealing with the slicing and stuff like that? Yeah. All right, so see, that has a lot of output stuff, and I'm wanting something short. Oh well, okay. The make file down at the bottom. For running our normal tests, we're going to gtest filter is equal to expression dot string index, and that is just so that it only runs the one. All right. Now let's go back. Where do we think this is failing? I'm going to start off on the program execute. And on the print, there we go. And I'm just going to see out printing something. And it's going to be result arrow dump end line. Will that work? Let's just see what happens. Okay, printing something CBA ABC, and I know that all of those should be added together to get this CBA ABC. And now let's see what, and we'll say cout after print, and we're going to say this arrow computed expression out arrow dump. Whoops. And just see if it grows. We're never getting anything. Okay. So that means our plus equal is failing us. So where can we look at that? Let's go to the innermost one, Unicode string .cpp. On the plus equals, we're going to say cout here. Here is always has nothing there. Why would that be? Let's go up a level. In other words, maybe it's not getting the right thing. So, computed expression string. Where is your plus equal? Oh, it's right here. So this val plus is equal to right-hand side val. Here, this arrow val, and space, and then rhs.val, end line, and then cout the aftermath, this arrow val. Now, do I have stuff written for all of that? So Unicode string, do I have a way of turning that into just a string? It's a very good question. Unicode string, subster, length, bytes length. Oh, if I just cast it to a string, that should be fine. Just to see what's in them. All right, so that's weird. Look, here we're saying it's empty and a C, which, by the way, I would expect, and it ends up being nothing. Let's plus equals right-hand side value. Oh, do you see what it is? I do. This should be a plus equals. If this all works, I'm going to be unhappy. Hey, it works. Okay, so let's remove debugging code. No, I didn't mean to do that. Oh well. I'm going to edit the make file. Where is this? It's at the bottom. Oh yeah, gtest filter. And now let's remove the before something, after something. Where is that going to be? Oh. And I'll just add a comment here. Both are private member and result are so combine them here. All right. And look, all of our tests are passing. It's a glorious day. Now, is this safe yet? No. We're going to make one other change, and that is in the program.hpp. We're not going to have this as something private. The output, we can have it public, but not our computed expression out. I'm going to delete that, and we're going to put it, come on, under the private stuff. Code stack. I'm going to put it right before the result. Okay, and now it's not going to like where I have it here. So we're going to need to delete all of that and put it there. The only problem is now we're not going to have a way of, well, do we need to access it at the end? Not yet. Not yet. Yeah, okay. As of this moment, we are at a steady state. So what I'm going to do, let's check all of our diffs to make sure that And this is going to be a refactor of print. How about refactor print so that it to a computed expression rather than directly to a string. Nothing else is working. Nothing else, or nothing else has changed. We haven't fundamentally changed the way our program works yet, but we made a change so that everything would still work. And then the next part is where things would get more interesting. So the question is what's the next change that needs to be made? Well, now I'd mentioned we want our computed expression string. We don't want to just add to the UTF-8 representation. And by the way, when we add to it, that should have nullified any results that it had. So, yes, I'm stopping and thinking for a long time on this because I'm wanting to make sure I do this right. I think I'm going to check the print output. You know what? We met that, and I am not going to push this any longer. So it's almost midnight my time. In the next episode, we're going to change our print output. In fact, while I'm talking, I'm going to make docs-pdf. Okay, so in the next one, I'm going to refactor the computed expression string so that it stores, instead of just one UTF-8 encoded string that it just adds to, it's going to store them as parts. And we're going to keep track of maybe how to... No, I'm not even going to do that yet. We're just going to store them as parts. That's what we're going to do. And when we need to dump them, then we will combine them into one big string at that time. I think that's good. All right. Do we have changes? Yes, we do. Docs. For episode, was it 60? Episode 60. I cannot believe that. Episode 60. Huh. Pushing it up. Okay. And we will tag episode.060. Our message will be the same. It's there. And the last thing we normally do is just kind of see where we are. We're going to definitely blow past 10,000 lines of actual code. And I'm okay with that. Again, it's not about how many lines of code it is, but lines of code is at least a decent metric of letting us know, have we been doing any, actual work? So, all right, where does this leave us? Like I said, we're going to make the computed expression string, store the parts, and then after we do that, we can, and that's going to be a little bit of work because it's not just that the fact that when it outputs it needs to store it, but what do you do on the slice? Well, you have to slice into those different parts. Yeah, that's going to be a little bit of work. The comparison is going to take some work. The less than is going to take some work. So none of it's straightforward anymore. So that's why I'm not trying to tack it onto this. I'll worry about that. That's a problem for future Corey to worry about. No, I'll get to that pretty soon. But as always, hey, thank you for joining me. And I think that our programming language is about to get some much needed features that will benefit us greatly in the long run. Thank you again for joining. Hope it's been enjoyable and or entertaining and or educational. Those all three start with an E. I doubt I hit multiples of them, maybe only one. I'll see you next time. Bye.